Good day, class. This is the first video lesson for the last unit of the course, and we begin this lesson with a look at oblique triangles. So these are going to be triangles that do not have a right angle in them. You'll see I've drawn the general triangle here at the top of the page. We're going to be using uppercase letters for those angles and lowercase letters for the side lengths. And you'll notice side A is opposite angle A and so on. So this is the triangle to which we will refer. We're going to need to use some new trigonometry for these types of triangles, and these are the laws of sines and the laws of cosines. For the first two cases, we will need only the law of sines. So these are the cases that I will concentrate on for this first video. You can see that we have A over sine A is equal to B over sine B, and that is equal to C over sine C. When we use the law of sines, we only ever use two fractions at once. In other words, we set up a proportion. Okay, so again, we're going to have 4 cases in total, but for this first video, we will look at only the first 2 cases. So here is case 1. In case 1, we will be given 2 angles, and we will also be given 1 side length. And here is the example I'm going to solve with you. So you can see that we are given angles A and B and also side A. So what is it that we need to solve for? We are going to need to find angle C and sides B and C. So when we solve the triangle, that means determining these 3 quantities. Okay, so let's begin together. Angle C will be very easy to determine since we know that every triangle has 180 degrees. So we can simply use subtraction like this from 180, and that is going to give us 97.8 degrees for that angle. Okay, so that is now determined, and now we can try to find the side lengths B and C. And we can do this with the law of sines. The key to this problem is that we know not only side A, but also angle A. And that means that looking here at the law of sines, we have this fraction here fully specified. So I'm going to use it and set it equal to B over sine B, and also use it setting it equal to C over sine C. Okay, just like this. We're going to have A over sine A equals B over sine B. And as soon as I'm done with that, I will also have A over sine A is equal to C over sine C. Okay, so we're using that one ratio twice. Okay, and again, that's because not only do we know side A, but we also know angle A. So this becomes 226 over the sine of 32.5 degrees is equal to side B, which we're trying to determine, over the sine of 49.7 degrees, like this. Okay, and now to solve this, we cross multiply. So I will cross multiply in the direction of the variable first. So we get b times the sine of 32.5 degrees is 226 times the sine of 49.7 degrees. So b is found by dividing that by the sine of 32.5 degrees. Okay, and this is easily just put into your calculator, so I can show you this one. 226 sine 49.7 divided by the sine of 32.5. All right, and that's side length B. I'm going to round it to 3 significant digits like this given side length, so 321. Like that. So I can cross that off my list. And we will use this same ratio on the left side here. And on the right side instead, we'll be finding side C, which means we have to use the sine of angle C, or 97.8 degrees under here. Okay, so once again, I'm going to cross multiply in the direction of the variable first. And when we go to solve for side C, we're going to use division. Like that. Okay, so once again, just put this directly into your calculator. So 226 sine 97.8 divided by the sine 32.5. All right, so there is our side length. And again, I'll round it to 3 significant digits, and that will be 417. Okay, so that is an example from case 1, the case where you're given 2 angles and 1 side. And again, what was the whole key to the solution here? Right here, I'm going to put a box around it here, maybe, just to highlight what was the key. The fact that in the problem, we were given both the side length and the angle called A. In other words, we were given a side and the angle opposite it. And that's what allowed us to use the law of sines. Okay, so let's continue now. We're going to go on to case 2. So that's case 1 now complete because we did find the 1 missing angle and the 2 missing sides. So case 2 is called the ambiguous case, and I'm going to explain why. In this case, you will be given 1 angle and 2 side lengths. So here is our first example. We have angle A given and sides A and C are given. So let's list what it is we need to find. It appears that we need to find angle B, angle C, and side B. So those are the 3 unknowns this time. Now, how can we begin the problem? Well, we have this again, both side A and angle A, which means we begin with the sine law, and it will be just like this. Side A over the sine of angle A is equal to, now we're given side C, so the first thing we're going to be able to find in question number 1 here from case 2 is angle C. Okay, because I know this quantity, and this quantity. So let's substitute. We're going to have 112 over the sine of 27.6 degrees is, side C is 165. So here it is. The first thing we're going to determine is angle C, like that. Okay, so cross multiply in the direction of the variable first, and that will look like this. 112 times the sine of angle C is 165 times the sine of 27.6 degrees. Divide to isolate the sine of angle C. All right. And this, in turn, will allow us to find angle C. Okay, so ready? We're going to do this calculation together. So 165 times the sine of 27.6 degrees. So I'm going to push equals. And then I'm going to divide by 112. And I get this. Okay, so that's the right side here. So if I want angle C, of course I take the sine inverse of this. So shift sine, right? And look at what it says on your calculator display. Push equals now, and there's my angle. Okay, so angle C is 43 degrees. However, there is another possibility. So I'm going to split my page in half here. And on the left side, I'm going to write angle C is 43 degrees. Okay, so that is an acute angle for C. But there is a second possibility. And this is based on what we learned with the cast rules. So let's just refresh your memory on that. I'm going to write cast like this. The angle of 43 degrees is right here in quadrant 1. Now, before I took the sine inverse, you might recall we had a positive number in our calculator. It was actually this number, okay, obtained for the right side. So the sine is positive in quadrant 1, certainly. So that's the quadrant 1 angle answer for C. But look, sine was also positive according to the cast rule in quadrant 2. So the other possibility for angle C is 180 degrees minus 43 degrees. And that is 137 degrees. Okay, so this is why it's an ambiguous case. There are two ways, in other words, to draw the triangle if we're only given this information. One of those ways would have angle C as an acute angle. The other way to draw the triangle would have angle C obtuse. Okay, so now we have to find angle B for both of these scenarios. So angle B would be the third and final angle of the triangle. So it can be found using subtraction. The whole triangle has 180 degrees. 27.6 degrees was given for angle A, and in the left side solution, angle C is 43. So performing this subtraction, leaves you with 109.4 degrees for angle B. We have to do the same thing for the possibility on the right side. 180 degrees total in the triangle. Angle A was given to be 27.6 degrees. And in this right-hand side version of the triangle, angle C was 137. And carrying out that subtraction gives you 15.4 degrees for B. Okay, so again, the triangle on the left has C acute and B obtuse, while on the right it's the reverse. C is obtuse and B is acute. Okay, lastly, we can find side B for each possibility here. How can we do that? We keep the left side the same from our sine law, and we'll change the right side here. So it's still A over sine A equals, okay, and we'll have this on the left and on the right like this. Okay, but now we're trying to find side B. So if we put side B on top, then under it must be the sine of angle B, like this. Okay, so let's substitute what we know here. 112 over the sine of 27.6 degrees is side B over the sine of 109.4 degrees. While on this side, we use side B over the sine of 15.4 degrees, like that. Okay, and now solving for side B, cross multiply first. Okay, and we might as well do this one at the same time. So cross multiply first. And in each case now, simply divide by the sine of 27.6 degrees. It's a fair amount of writing for sure. Okay. And then you would just take out your calculator and type this in like this. And for the solution on the left, you will get 228 for side length B, while the triangle on the right will have 64.2 for side length B. So as far as the rounding goes in this problem, I made sure that my side lengths all had 3 significant digits, while my angles all had 1 decimal place. Okay? Okay, so once again, if you are in the second case, you will be given 1 angle and 2 side lengths. Okay, 1 angle and 2 side lengths. And also in case 2, you will have the same letter name. Okay, so in this case, we had both side A and angle A. And that's what allows us to use the sine law. When you go to find your first angle, your first missing angle, you must check for the possibility of both an acute quadrant 1 value and an obtuse quadrant 2 value. And this is what leads to two completely different ways of drawing the triangle. Okay, this is a tricky case, so we're gonna do one more together. Okay, so here we go. This is still case 2, the ambiguous case. We can see that that's true because we are given one angle and two side lengths. And we know not only side B, but also angle B. So what are we going to find? We need to find angle A, angle C, and side A. Now, we begin with the sine law. We set up this information in a ratio first. So B over sine B equals, now what we're given is side C, and that means under it we'll have the sine of angle C, like that. So we'll start with that. So, equal sign here in the middle. So we have 525 over the sine of 35.2 degrees is 412 over the sine of angle C, like that. Okay, this is bothering me a bit that I made that go all the way through. Let me just fix it, okay? All right. So from here, we're gonna isolate the sine of angle C. So cross multiplying. And then dividing. Okay, just like that. All right, and so now we punch this into the calculator. So it's 412 sine of 35.2 divided by 525, and we get this number here. Okay, so that's the sine of the angle. So this means that what we do now is the sine inverse. Okay, so that's the acute version of angle C. And again, since this is the ambiguous case, I'm going to divide my page in half. So on the left side, we write down this angle that the calculator gives us of 26.9 degrees. So that's the acute quadrant 1 version of angle C. Now again, with the cast rule, we know that a quadrant 2 angle is possible here since we had a positive value of sine. So what is 180 minus 26.9? It is 153.1 degrees. So these are the two possible values for angle C. And then we would continue from there to find angle A and side A on the left, and here also angle A and side A. But there's a problem this time with this right-hand value of 153.1 degrees for angle C. Can you see what's wrong about this problem? Remember, we already know angle B. The problem with this value is it's already too large for the triangle. If B is 35.2 and C is 153.1, look, we've already got too many degrees for our triangle. The triangle, which would also include angle A, can only have 180 degrees in total. we've already burst the triangle with just angles B and C. So this is not possible. So this second example is an example from the ambiguous case, which will have but one solution. Okay, so if you compare that with the last example, it was the same case, the ambiguous case, and we ended up with two possible solutions. But in this case, we will have just the one solution. So we found angle C. How many degrees are left for angle A? Well, 180 in the whole triangle minus 35.2 degrees, which was angle B, minus 26.9 degrees, which is angle C. So we do the subtraction and we find that we have 117.9 degrees available for angle A. So now we have both C and A. And so the last thing we're going to do is find side A. How will we do that? We'll set up this sine law, keeping the left side exactly the same and changing the right side. So let's do that. We're going to actually have side A on top, which is what we're trying to find, which means under it has to be the sine of angle A. Okay, so the same exact left side here. And on the right side, we need to substitute 117.9 degrees in the denominator. Okay, trying to isolate the little a here, cross multiply first. So A times the sine of 35.2 degrees is 525 times the sine of 117.9 degrees, and then divide. So we divide by the sine of 35.2 degrees, and that'll allow us to get our value for A. So just punch this in like this, and you will get 805. Okay? And again, for this example, I just made sure all of my side lengths had 3 significant digits and my angles each had 1 decimal place. And that's consistent with that rounding table we had in our trigonometry unit. Okay? Okay, so in this video today, we looked at solving oblique triangles, and we concentrated on the first 2 cases. Those cases allowed us to use only the law of sines. We did not have to use the law of cosines yet. The law of cosines will be used in case 3 and in case 4, and those will be presented in a second video. Okay? All right, so take some time to practice the first 2 cases that were presented today. Again, for both of these cases, you were given a side length and an angle with the same name. So these were both A, remember? And look, the same thing happens here. These were both A, so that's the key. And in example 2 from case 2, look, this was the key. These were both B's, side B and angle B. Okay, so if you like, I can put a little box around that like I did for the first one. All right, that's what allows you to use the sine law. And this is example 1 from case 2. We can put a little box here as well. All right. All right. Yeah, so have a good day. And when you're ready, you can take a look at the video with cases 3 and 4 as well.